Okay, so this video is going to be on graphing a quadratic in standard form. So I am going to do it two different methods. One method I'm going to utilize is just creating the vertex, and from the vertex I'm going to talk about the value of a and how the value of a changes the growth of your quadratic. And then another time I'm just going to use a table of values just to show you what's going on here. But either way, this is going to be standard form. Some textbooks may call it general form. I'm just calling it standard form because that's all I've ever known it to be called. So here we go. Let's go take a look at how we graph one of these things. So first off, my function is 3x squared. F of x equals 3x squared plus 30x plus 79. So what I'm going to do here, okay, is I'm going to utilize some formulas. So the first time we do this, just going to utilize formulas and utilize some knowledge and some patterns that any quadratic value creates. So here we go. So first things first, I'm going to look at A to know that my quadratic's positive. So I know over here I should have some sort of U-shaped somewhere along here. The next thing I'm going to do is I'm going to calculate the vertex. So there's formulas for the vertex, and the vertex is for the x-coordinate is the opposite of b divided by 2a. For y, it is c minus b squared divided by 4a. So I'm going to go ahead and calculate those very quickly. And what I get here is the opposite of b is negative 30, okay, divided by 2 times 3, and that is equivalent to negative 5. All right, so negative 30 divided by 6 is negative 5. And then I'm going to do 79, so c is 79 minus b squared, so 900 divided by 4 times 12, 4 times 3, which is 12. So that is equivalent to positive 4, because 900 divided by 12 is 75. So that is my vertex. So that's the first point that I plot. So 1, 2, 3, 4, 5, up 1, 2, 3, 4. So there's my first point. Plot it in. Okay, so the next thing I now need to do is I need to figure out, okay, how is my parabola going to grow? Okay, how is it going to change? And the way you figure that out is by utilizing delta y. So delta y is how much is it changing with respect back to the vertex, okay? Not from point to point, it's always gonna be with respect to the vertex. So the way you figure this out is you just talk about delta x, which means how much do you change? So if I go over 1 unit, then n is 1. If I go over 2 units, then n is 2. Okay, and all you have to do is utilize this idea, okay? So because you're talking about a quadratic, if you move over 2, you're squaring something, right? Or you're moving over 1. So basically, let me show you how I connect or get more points on here utilizing this idea. Okay, so let me erase my work from my vertex. So here we go. So if I move over 1, so to calculate my first delta y, okay, my first movement away from my point, if I go over 1, then I just square it. So 1 squared is 1, and I multiply that by whatever a is, so times 3. So 1 squared is 1 times 3 is 3. So if I go over 1 unit from my vertex, I go up 1, 2, 3. So there's my first point. Now, if it were negative 1, it doesn't matter because it's going to square it, which will make it positive 1. So if I move to the left one, I go up 1, 2, 3 as well. So there's my next 2 points. So over 1, up 3. Oops, sorry, wrong. Over 1, up 3. Over to the left one, and up 3. Now, if I had more room, okay, I would go over 2. So if I could go over 2, that 2 squared is 4, times that by 3 equals 12. So if I have a change to the right of 2 units, okay, then I go up 12. All right, and that's how you utilize this. So it will always be the amount that you move right or left squared multiplied by a. So in this case, if I go over 2, I don't have enough room to go up 12. So what I'm going to show on my graph here is that my point would be somewhere above here, so it's not going to, when I draw my graph, I'm not going to quite get to this line yet, so I'm going to finish my graph somewhere really close to the line, but not quite at it. So here we go, I draw my line in, and not quite at over 2 yet, but close to it, and I'm going to do the same thing, going the opposite way. And there you have it. That is a graphed parabola using formulas. So another one that we could have is if I need to make this via a table. So the first thing you do need to know, and there is no way of avoiding this, the best thing you need to know is that you have to know how to find h. You have to know how to find the x-coordinate of your vertex, and the x-coordinate is the opposite of b divided by 2a. So you can't avoid that. So that is the very first value that you'll need to plug into your table. because what you now need to know, and you should have studied, is that quadratics are indeed, okay, symmetric. So if I move to the right one and up 3, then I'm going to move to the left one and up 3. So no matter which direction I go, the output will become the same. Okay, which means the y coordinates will be the same if I go to the right 2 or I go to the left 2. The y coordinate from the vertex will be equivalent. So here we go. So first things first, to find h, all right, that's the first value I need to find for my table. So I'm going to say the opposite of b, so the opposite of 4, so -1 times 4 divided by 2 times a, and a is -1, so multiply it by -1. I get h is now equivalent to -4 divided by -2, which is 2. So h is 2. So now I'm going to make a table. So I make my table, and I go x and y. Now, I don't place 2 at the top, because I'm going to need 2 numbers to the left and 2 numbers to the right of my vertex. So the vertex, I will say, is 2 numbers to the left of 2 are 0 and 1. So 0, 1, 2, and 2 numbers to the right of 2 are 3 and 4. So there's my x coordinates. So now all I simply do is I plug these values, okay? And I always, by the way, I always choose 5 points. If you only have to choose 3, great. But as soon as you get this h, subtract it by 2, that's your starting point. Add 2 to it, that's your end point, and fill in the integers in between it. So in this case, I have all whole numbers, right? So I don't have any negatives to worry about, which is kind of fun. Sorry, I should have, my equation here should be a square. Okay, so now from here, all right, what I'm going to do is I'm just going to plug my x coordinates in, just like you've always done in any course you've ever taken. So 0 squared is 0 times -1, right? So I go and I plug these values. I'm going to plug 0 into this equation. And when I plug 0 into this equation, that goes away, and I'm left with 1. So one of my points is 0, 1. Okay, when I plug 1 in, all right, I get 1 squared, which is 1, so I have -1. So I get -1, so plus 4 times 1, which is 4, plus 1. Well, those go away, and I'm left with 4. Now, the reason this is nice is because if 0 is 1, then I also know symmetrically that the 4 will be 1. And if 1 is 4, I also know symmetrically the 3 will also have an answer of 4. So I just saved myself some calculations. Please, I also would say to you for you to do the same if you're doing it via a table. So the only thing I really have to plug in now is 2. Well, 2 squared is 4, so this is -4 plus 4 times 2, which is 8, plus 1. Okay, so -4 plus 4 is 4, or plus 8 is 4, plus 1, you get 5. So now what I have is 5 points to plot. And then after I plot my 5 points, I'm going to connect them with a smooth curve, and I'm done graphing them. So here we go. I go to the point 0, 1. So here is the point 0, 1. I go to the point 1, 4. So 1, up, 1, 2, 3, 4. So point 1, 4. I go to the point 2, 5. So point 2, 5. So over 2, up to 5. There we go. I go to the point 3, and I go to 4. And then I go over to 4, and I plot the point 1. So why is it that my graph opened downward? And how should I have known that I plotted my points correctly based off of this? Well, if you notice, A is negative. So if anytime A is negative, you'll have this shape of more like an N as opposed to a U. So this parabola will be opening downwards. So my last step to do here is connect it with a smooth curve. All right, so there we go. And there we have it. I've now got my parabola graph. So that is how you graph parabolas. So you can either utilize, okay,